In this section, in the Math 111 course, we're going to be looking at section 5B, which is called Should You Believe a Statistical Study? And we will be developing what we call statistical thinking skills. So in this section, we're looking at a statistical study that has already been conducted. For example, if you're doing research for some project, either here at school or at your place of employment, you want to develop something that we call statistical thinking skills that allows you to analyze that statistical study. So we're going to be looking at 8 guidelines for evaluating a statistical study. These 8 guidelines are all listed on page 301 in your textbook. We will be looking at each one separately with examples to follow each of the 8 guidelines. So the first guideline that we're going to look at for evaluating a statistical study is to identify first the goal of the study, second the population being studied, the third thing is the type of study that was used, and lastly, does this study make sense? In the following example, we're going to analyze the study that was conducted using guideline number 1. So in this particular example, a study was conducted by Procter & Gamble to determine if ZzzQuil is effective in treating cold symptoms. They decided to use, Procter & Gamble that is, who was doing the study, a single-blind experiment for this study. Okay, so to analyze this example, we first want to look at the goal of the study. Well, of course, the goal of this study was to determine if ZzzQuil was effective in treating a cold. The population being studied would be persons that have a cold. The type of study that was conducted was the single-blind experiment. And lastly, does it make sense? In other words, does this setup make sense? Well, in reality, since Procter & Gamble is the one that actually conducted the study, we should not have used a single-blind experiment, but perhaps a double-blind experiment would have been the better choice, so that Procter & Gamble doesn't know who receives the ZzzQuil and who receives the placebo. The second guideline that we're going to look at in evaluating a statistical study is to consider the source. And we want to determine if the researchers were biased in any way. So in the following example, we're going to use guideline number 2. So the example says, according to a nationwide survey, scuffed shoes was the most common reason for a male seeker's failure to make a good first impression. This poll was commissioned by Kiwi Brands, which is a producer of shoe polish. And what we want to determine is, was this biased by the researchers? And the answer to that is, of course, yes, because the researchers were makers of shoe polish. The third guideline for evaluating a statistical study is to look for bias that may prevent the sample from being representative of the population. So there are 2 types of bias that we're going to study, and the first type is called selection bias. In selection bias, researchers select their sample in a way that tends to make it unrepresentative of the population. The second type is participation bias. And in participation bias, people choose whether to participate. So people who feel more strongly about the issue are more likely to participate than those that do not feel so strongly about that particular issue. A good example of where selection bias did occur is we're studying the heights of college men. And suppose the sample that we choose are members of the men's basketball team. There is obviously selection bias in this sample due to the fact that most basketball players are much taller than the average college male. A good example where participation bias would occur is on the show American Idol. What we're trying to determine is who is the best singer or performer on the show. So the population is the American citizens. The sample then are persons calling in. And the sample is composed of persons who choose to participate. So there is participation bias in this sample. The fourth guideline that we're going to look at is number 4, look for problems in defining or measuring what we call variables of interest in the study. And the variables of interest are the items or quantities the statistical study seeks to measure. So a good example of number 4 is a survey was conducted to determine whether Norwegian citizens are happier than American citizens. The variable of interest in this survey is happiness. So the difficulty here is, how do we define happiness? Happiness is a very subjective term. It's also difficult to quantify happiness. So therefore, the variable of interest in this one is very difficult to analyze and interpret the results from this survey. Guideline number 5 in evaluating a statistical study is to watch out for what we call confounding variables. And confounding variables tend to confound the study's results. The definition for confounding variables are variables that are not intended to be part of the study. The variables of interest are what we're trying to study, but these confounding variables get mixed up with the variables of interest, which makes it very difficult to determine the study's results. An example of where a confounding variable came into play is a University of Vermont professor implemented a new attendance policy in a particular semester. And his policy read that 1% will be deducted from your final grade for each class missed. The result is at the end of the semester, better attendance did occur. So the University of Vermont professor concluded that the attendance policy was effective. What the University of Vermont professor failed to take into account was a confounding variable. And what had happened that semester is that the weather was very mild, and it was a very mild winter. University of Vermont can get very large amounts of snow, which of course would affect the attendance policy if the weather's bad. So the confounding variable of weather is confounded with the variable of interest, which is the attendance. So the result from that and the conclusion may be incorrect because of that confounding variable of weather. The sixth guideline in evaluating a statistical study is to consider the setting and wording in surveys. So in guideline number 6, we're going to look at a specific example which analyzes the order of the question. So for example, this question was in a survey. Would you consider traffic to contribute more to air pollution than industry? Most of the time when there's a choice, the first choice given is the one that's chosen most frequently. So in this particular wording, traffic was chosen as contributing more to air pollution than industry. Okay, in the second wording, all I did was flip-flop the words industry and traffic. So now the question reads, would you consider industry to contribute more to air pollution than traffic? So in this case, most people chose industry as the culprit for causing the air pollution over traffic. So the first choice in a survey question is the one that's chosen most frequently in most cases. The seventh guideline in evaluating a statistical study is to check that the results are presented fairly. And presented fairly, what we're going to look at in this section is misleading graphs. A good example of number 7, where results are not presented fairly, is in this misleading graph. And these are two bar graphs. And the question that was asked is, have you ever been hit by a computer virus? So your answer to that is either going to be yes or no. So the results are depicted below in the two bar graphs. The one on the left starts the scale at 40,000 and ends the scale at 120,000 on your vertical scale. And of course, approximately 100,000 said yes, and approximately 60,000 said no. The same data is displayed on this second bar graph on the right-hand side, and in the second bar graph, your vertical scale started at 0 this time, as opposed to the 40,000, and ended at 120,000, which is the same as where we ended on the bar graph on the left. As you can see, the differences are exaggerated on the one on the right-hand side, the left-hand side, where the scale started at 40,000. Most of the time, when you're doing a bar graph, you should start your vertical scale at 0, so as not to exaggerate the results in a way that makes the results presented unfairly. The eighth and final guideline that we're going to look at for evaluating a statistical study is to consider the conclusions. And ultimately, we want to determine, did a treatment have a significant effect? In this section, we're going to look at statistical significance versus practical significance. An example of number 8, where we're looking at the conclusions, is in this example, Gene Research Group developed a procedure to increase the likelihood that a baby would be born a girl. So in a clinical trial, 112 out of the 200 couples studied actually had girls. And what we want to do is a statistical test to determine if it's statistically significant, and we also want to look then at the practical significance of that. So a statistical test was conducted, and it was determined that yes, there is a statistical increase in the amount of girls that was had using this particular procedure. Now we have to determine if that increase from 100, which is what we would expect, to the 112, is different enough or an increase enough for us to actually use that procedure. So we're looking at the practical significance of that. So you have to determine, based on cost of the procedure, time that you would need to do the procedure, etc., if that's practically significant to you. This concludes section 5B, which is called Should You Believe a Statistical Study, where we went through the 8 basic guidelines for evaluating a statistical study. In reality, when you're going through this, you should look at all 8 guidelines at once, and there may be other ones that you want to look at as well. And what we're doing is developing your statistical thinking skills in a study that has already been conducted.